Thank you, everyone, for tuning into the Cloud Native FM podcast. This is your host for this show. My name is Saim Safdar, and I am the co-founder of Cloud Native Islamabad and the organizer of the KCD Pakistan, and also the CNCF ambassador as well. So, thank you very much for tuning in, everyone, regardless of where you are or watching us or listening or watching to us or watching to the recording of this show. A very, very warm welcome to this show, a show which brings in the latest and greatest news from all the ways from the Azure, Google Cloud, AWS, from the container world to the cloud native world to the CNCF landscape to help you keep up to speed or where you need to be focused on more and where you meet the brave mind and awesome community member of the 2023 open source projects. So today, what we are covering today, an architect sees things differently from an engineering point of view. This is called architectural thinking, or is more than just thinking about architecture. There are multiple aspects to think like an architect. What are the responsibility of an architect? They are responsible for making architectural decision and ensuring compliance. And it's not all about technology. Having impersonal skills and knowing how to navigate politics is just as important. And how to stay up to date with the latest and greatest technology trends. In this session with Robin, we will discuss everything you need to be succeeded as an Azure architect. And we have so much wonderful topic to talk about and wonderful news from the MS build as well. So thank you very much, Robin, for being on the show. Over to you. You can start discussing about the presentation you have prepared. And plus, number one, can you introduce yourself to our audience?
Absolutely. So happy to be here. Thanks for having me. Yeah, I prepared a presentation which includes a slide where I introduce myself. So I can do that there, if you agree. And it's a
Yes,
little bit weird that because normally I run the stream and I use StreamYard, so now I'm on the other side, so I don't have all my controls and stuff. So that's a funny dynamic.
yes.
Okay, I'll share my screen and switch. So you should be able to see my presentation.
Yes, absolutely. Perfectly fine for me. And hope everybody in the chat also can see the screens well. Over to you now, Robin.
Thank you. All right. So, how to succeed as an Azure architect? All right. So, this presentation includes everything you need, or almost everything you need. I will explain a little bit later why. So, let's introduce myself first. My name is Robin Smorenburg. I live in the Netherlands, so that was the Dutch pronunciation of my name. And I'm a lead cloud architect at NordCloud, and we're an IBM company. I'm the co-founder of Streaming Clouds, together with Kevin Evans. I'm a Microsoft Azure MVP, and I'm a fellow CNCF ambassador. So before we start, I would like to take you a little bit on a journey, the one that I had with my career. So let's start at the beginning. So I started back in 2008 as a service desk engineer and became a service desk manager in 2012, running the service desk, prioritizing items, doing the planning, handling escalations, basically everything that you have to handle when you run a service desk. 2015, I decided that I wanted to do more than just solving issues or troubleshooting problems, or I wanted to create instead of solving things. And now I'm still solving things, but at least not the issues of people directly. So I started working as an IT consultant. And at that time, I only worked with the Microsoft stack. I did some VMware, but everything was Windows Server, Windows, Exchange, SharePoint. And that was my first job where I started working with Azure. And it was ASM back in the day, not even ARM yet. And I was also running the data center clusters that we had. So we had multiple Hyper-V clusters providing infrastructure as a service to multiple customers. So the whole idea of having a unlimited data center at your disposal where you can just spin up machines, which is managed and owned by Microsoft, just blew my mind. And I'm like, whoa, what is this? So eventually started working more and more with Azure. And I decided that in 2019, I wanted to let go of Microsoft 365 and all the other technologies and just focus solely on Azure. Did a lot of infrastructure as a service or traditional infrastructure migrations, and eventually moved up the ladder, if you will, and became a cloud architect in 2020. And that led me to becoming a lead cloud architect in 2023. So this is approximately 15 years of spending time in the technology industry and working my way up all the way from service desk to becoming a lead cloud architect at Nordcloud. So let's start with the responsibilities, right? Let me get up my notes so I don't forget anything. But defining a complete list of responsibilities as of an architect is almost impossible. The duties differ for each company and sometimes even per project. So you design the systems that, combined with the application, solve specific business problems, the solution. Right? So you have the application, you have a system, and together that will create the solution. So applications are software programs, right, performing a specific function or a specific task. And systems are a collection of components working together to achieve a common goal. So I defined the following list of responsibilities based on my experience. All right, so let's start at the top, right? So identify architectural characteristics. So what are these? So we'll dive into these a little bit more. Make and govern architectural decisions, right? Somebody has to make the decisions, which components to use, etc. And we need to ensure that these decisions are followed and implemented by the team, which you usually lead or you are part of the implementation, but usually you work together with a couple of other architects or cloud engineers implementing the solution. Then you need to analyze and improve the architecture because technology keeps evolving. So it can be that the architecture or the solution you created a couple of months ago is not efficient and as efficient as it can be anymore, right? Because Azure just keeps on innovating and adding new services and evolving services, etc. And then you need to stay up to date with the latest technology trends. So that's something we will discuss a little bit later. The latest Microsoft Build news revolving cloud native. And that's one way to stay up to date with the latest technology trends. You need to create diagrams and be able to present the architecture to your stakeholders and, of course, to the team as well. And eventually, you start leading teams and leading projects. So you need interpersonal skills. You need to know how to navigate politics, and so on and so forth. So the key to success as an Azure architect depends on understanding the responsibilities and practicing the needed skills. So let's explore each of the duties and skills in more detail. Before we do, this is part one. While creating this session, there's also a blog post coming out in June where you can read all of this. But while I created this session, I came to the conclusion that it's too much to cram into one session. So this is part one, where we focus on the first three responsibilities. And then in part two, somewhere further down in June, or maybe the beginning of July, depending on our schedules, I'll come back if Seam still wants me, and then we'll discuss the other three responsibilities in detail. All right, so with that out of the way, let's move on to architectural thinking. All right, because this is something that is woven throughout everything you do as an architect. All right, because besides taking responsibility and practicing the skills, you must think like an architect. But what does that mean, right? What does architectural thinking mean? So it involves understanding the big picture. It requires understanding how different components fit together and interact to create a solution. Architectural thinking sets an architect apart from an engineer and includes more than just thinking about architecture and technology. Now, there are multiple aspects to adopting an architect's mindset. Technical breadth and depth. So what does that mean? Understanding the business drivers. So what's the reason behind what we're doing? An application that doesn't add value to the business or recurring revenue or any form of value is basically not delivering anything, right? Same goes for infrastructure. Infrastructure that doesn't run an application or doesn't deliver the same business value is useless. And then eventually we have analyzing trade-offs. So you need to be able to make decisions, but these decisions are not as transparent, right? Am I going for this or component, or am I going for that component? Do I use a web application firewall based on an application gateway, or do I go for front door and enable the web application firewall there? So these things are important to include and try to ingrain in your way of thinking. So what does technical breadth and depth mean? As an engineer, you need a significant amount of technical depth to be successful, right? You're the subject matter expert in certain areas, with the ability to implement these technologies and services. On the other hand, you have an architect, right? As an architect, breadth is more important than depth, because you need to be able to make certain decisions, and these decisions include the big picture, right? So you need to see everything from an architectural point of view, matching capabilities to technical constraints. So you can also look at depth versus breadth, as in knowing everything about something versus knowing something about everything. So let me repeat that once more. Depth versus breadth is like knowing everything about something versus knowing something about everything. So in today's technology landscape, you must narrow your focus even as an Azure architect. And it's impossible to keep up with the speed of innovation and change across the whole landscape. And you need foundational knowledge of computing, storage, databases, networking, security, because these components are part of almost every solution. I'm not saying you need to be able to exactly explain how computing works, right? But I'm talking about the fundamentals of CPU and RAM, for example. Or if you look at storage, right? What's the difference between file, block, and object storage? Or, structured and unstructured data, if you look at it from a data perspective, or, relational and non-relational databases, and so on and so forth. And then you need to understand the business drivers, right? Like I already said, you need to know the reason behind why are we doing what we do? What is the business value that we're delivering, right? And then if you understand the business drivers, you need to translate these requirements into architectural characteristics, such as availability or scalability or even security. So this is a considerable part of architectural thinking. And like I briefly mentioned at the beginning, right, understanding the business drivers requires communicating with your stakeholders, interpersonal skills, communication skills. Well, that is interpersonal skills, but that's what I mean with interpersonal skills, how to deal with people, basically. And you should also know how to navigate politics, right? Because usually larger organizations or even smaller organizations nowadays have a form of politics going on. And finally, we have the trade-offs, right? So you need to be able to make decisions based on what's most important, right? Especially in the cloud, you pay for everything that you use, right? Pay as you go. So the more you use of something, the more you pay. So the more efficient your solution is, the cheaper your solution becomes. Right? So you need to be able to understand these trade-offs. to be able to make the right decisions and also to be able to clarify why you make the decisions that you just made, right? Because people will always challenge your decisions or your architecture or your solution. So let's take a look at architectural characteristics. For that, I take a sip of my water. So when architecting a solution, there are requirements from a functional perspective, right? Functional requirements. So what's the problem we're solving, or what's the functionality it should include, and so on and so forth. So usually people are just focusing on the functional requirements, but we also have something called non-functional requirements, or often referred to as non-functional requirements. I'm not really a big fan of that name, basically, because how can you have someone pay a lot of attention to something which is called non-functional? So a better way to call that is architectural characteristics. So what are the characteristics of the architecture on top of the functional requirements? A good thing to note is that these are just as important as the functional requirements, right? And it's not something you just sprinkle on top, like, oh, let's add a little bit of observability on top. It's usually something that's ingrained in the solution. And then there are many architectural characteristics, also known as the ilities, because most end on ility of complexity or security, observability, now, etc. Right? So it's important that you keep it as simple as possible. So that's why I put it as a subtitle underneath the title. And every architectural characteristic adds complexity, and it usually impacts other characteristics. So if you look at performance versus security, right, encryption will hurt your performance to a certain degree. Right? So the more security you add, the more you will impact your performance. And sometimes that's just the way it is, because performance or security is more important than performance, or the other way around, right? So it's important to minimize the number of characteristics. So, reach out to your stakeholders, have them define the top 3 of the essential architectural characteristics, consolidate that into one list, and have them sign off and approve and sign off on these characteristics, right? So this way you end up with the 3 most important. So what are the most common architectural characteristics? We have performance, right? The ability of a system to meet performance requirements, or availability. The ability of a system to remain operational and accessible when needed, and often measured in availability over a percentage, right? 5 nines, 4 nines, etc. Then we have scalability, right? The ability of a system to handle increasing load and traffic by usually automatically adding compute or nodes, right? From a Kubernetes perspective. We have reliability, right? Performing the intended function without failure, which usually relates really closely to availability. We have maintainability, right? The ability of, or the ease of which a system can be modified, repaired, or enhanced over its lifetime. Right? And this also includes things as documentation or code readability. A lot of ility, by the way, and then we have continuity. Right? So maintain the intended function during a disaster. So think about disaster recovery and backup. Security, the ability to protect against security threats, data breaches, or other cyber attacks or stuff like that. And observability, right? Gain insights into the behavior and performance of the system through metrics or logging, tracing. Of course, there's a whole list of architectural characteristics or ilities available on Wikipedia, for example, with a thorough explanation of what all these mean and how they're measured and etc. But there's not like a unified list that every organization uses. And so it's important to have a common understanding of what certain things mean, so that you can have good discussions with the team. So that's nice, right? We have the architectural characteristics. Hopefully everyone now knows what these mean, right? And also we know a little bit about how to identify them. But let's look at that in a little bit more detail. So identifying your architectural characteristics requires knowledge of the business domain, discussing the requirements with your stakeholders, selecting the top 3 most essential characteristics, like I already mentioned, consolidating that into a final list. And something else to take into consideration is that explicit requirements often lead to specific architectural characteristics. So think about processing medical records, right? What will that do with the architectural characteristics of your solution? That will probably put more or emphasize security over performance, right? We cannot have a data breach revolving medical records, right? So that usually means, or in the United States, that means that you have to be HIPAA compliant, right? And HIPAA is like then the industry standard for everyone who processes medical records, which exactly tells you what you need to implement, right? Or the ISO, right? The International Organization for Standardization, or we have NIST, or there's a whole list of industry standards developed by these organizations, and these standards emphasize specific characteristics. So research if your organization needs to adhere to certain standards, and if required, use the standard to identify architectural characteristics. Then after identifying your characteristics, right, what is most important for our solution from multiple perspectives, we need to make decisions, right? And the right decisions guide the team in implementing the solution. Right? And good decision making includes gathering relevant information, documenting your decisions, including the reason, and communicating your decision. Right? If nobody knows about the decision, then how can someone have an opinion about it, or approve it, or implement it? And it's really important to include the business and technical justification, because just the business justification is usually not enough, just as that the technical justification is usually not enough, because the why is usually more important than the how. Right? Because if we have a diagram, the diagram will help us understand how something works, but the diagram never explains why certain things work the way they are, or the way they work, or why are they implemented in that way, right? And something else that's important is to include the team in the decision making, because usually the team includes the subject matter experts around the technologies that you're going to be using for your solution, right? Depth versus breadth. And then you want to record or document your solution, your decision. And to do that, you can use the Architecture Decision Records framework, which is a framework that has been developed for the sole purpose of recording your decisions. And usually your records are stored as a document or a wiki page. So if you start recording your decisions, this is a pretty good framework to ensure that you include everything that you need to include to be able to later on analyze and improve the architecture or defend certain decisions, right? And it can be that the architect who implemented the solution or designed the solution and was part of the implementation moved on to another project. Or in my case, I'm usually an external consultant, right? So whenever the engagement or the assignment finishes, then I move on within the same organization if it's a big customer, or I completely switch to another customer. Right? So it's really important that you register or record your decisions. So let's start with the title. Right? So a short descriptive title for the decision, followed by the status. Right? So that can be approved or denied, accepted or deprecated. Then the context. So the background and context leading up to the decision. So why are we even thinking about deciding on something? Then the decision itself, including any alternatives considered. The consequences of the decision and any risks associated with the decision. And finally, we have a references field where we can add relevant documentation supporting the decision, links or other resources, right? So this way you have like a nice overview of certain decisions, like, hey, this is the reason why we went with Kubernetes over container apps, right? Pretty big decision. Or, we decided just to use the West European region, or, other more complex decisions that you have to make. Something else that the ADRs or the, architectural decision records are really good for is documentation or defining organization-wide standards. Right, so if somebody wants to know what the standard is, then you can refer them to a certain decision record, which includes all the information that they need to adopt that certain standard, including the why. And something else that they're ideal for is communicating the decision, right? So what you do, or what you usually see, is that a lot of people have this email thread going on. And somewhere in that thread, there is a decision. Some people don't read their email or have certain, automated records in their inbox. So it's important that you share the location of that decision record so that everyone can see the latest update or the latest status of that specific decision, and that you have like a database or a Git repository is even possible if you use Markdown, or you can use Confluence or Azure DevOps Wiki, or any system where you can add documents, basically, or as simple as a SharePoint folder or a folder in Teams, if you will, right? Where you add Word documents with a certain template, where you add all these fields, and then you can add information that relates to your decision. All right, so we identified the architectural characteristics. We discussed architectural decisions and how to keep track of your decisions, how to share them, etc. And something else, which is what is really important, is ensuring compliance. So it's vital to govern architectural decisions. Are they implemented correctly? So Azure has multiple tools and services available for the governance of decisions, Azure Policy being one of them. Right? Azure Policy enables you to enforce guardrails. So there are like hundreds of built-in policies. I think it's 500 plus nowadays, even more. And initiatives, which are a collection of policies which can be based on NIST or ISO or any other industry standard we briefly discussed, right? So these will actively monitor your environment and your solutions, and will tell you or will even deny certain deployments if they don't adhere to these standards, right? So you prevent the deployment of something that's non-compliant. Something else that you can do, and that's a little bit more of a CSOE or platform engineering kind of approach, is defining blueprints, right? Or archetypes, architecture types to ensure compliance. So a blueprint represents a repeatable collection of resources. And you can, for example, use Terraform to write reusable opinionated modules. And we're not talking about, hey, let's create a module for virtual network or a module for something that someone else needs to completely configure, but create opinionated implementations of different architecture types. Like, hey, you need to run a web app, right? We have A, B, and C for you available. Which one will suit your needs, right? And that one is then completely opinionated, includes a network, includes other services, certain security settings, permissions, you name it, you can include everything in there. And then you parameterize certain configurations, and then someone can just deploy that. And they don't have to worry about, am I compliant? Am I following the organization standards? So that's a really good way to look at it. And then if you even take that a step further, you can think about self-service, right? So you create like this developer portal, if you will, or a catalog of available building blocks that people can consume and deploy themselves, right? So with that out of the way, let's move on to architectural vitality, or analyzing and improving, if you will. Because technology changes constantly, and especially Azure and the other clouds, but Azure MVP. So you can find me in Azure all day, basically. So this means that the architecture and its decisions must be reviewed regularly. Things changing, right? So this relates to architectural vitality, which means the ability of an architecture to adapt and evolve in response to changing business needs, technological advancements, and other factors. So a vital architecture supports innovation by accommodating new technologies to remain relevant and effective under varying circumstances. So analyze and improve the architecture with the recorded architectural decisions, right? Because these contain the context, the why, right? The reasoning behind certain decisions. Combine that with the diagram, which explains how everything works, right? The how. So that means you have the why and the how, which will enable you to make effective new decisions, right? Based on your analysis and being able to improve the architecture. Of course, eventually new decisions have to be recorded. Old decisions have to be deprecated. Diagrams need to be updated, but that will lead to an implementation with improvements together with the team. And this way you make sure that your architecture remains vital, right? And what is a good cadence to do this? It can be yearly, it can be monthly, depending on how many resources you have available. It can be quarterly, right? Anything that ensures that your architecture stays up to date. Okay, I already discussed this. So let's recap a little bit. We have a list of responsibilities, which in my opinion are the keys to success. Right, so you need to identify architectural characteristics, make and govern architectural decisions, analyze and improve the architecture, followed by staying up to date with the latest technology trends, creating diagrams and presenting the architecture, and eventually leading teams and projects. This is what we discussed today. This is what we'll discuss in part 2. So somewhere in June, maybe the beginning of July. And then finally, where to find me. Right? So I'm on LinkedIn, first name, last name. Twitter, first name, last name. You can find me on Robino, that's my blog, where I will be eventually publishing this blog post, because to be honest, it's not completely done yet. Just keep fiddling around with everything and optimizing whatever I wrote. And you can find me on streamingclouds.io. That's the live together with Kevin. And yeah, that's what I have for today.
Awesome, Robin. It's been a great conversation. I learned a lot. There are a few questions before we're heading up to the conversation around
Yeah,
MS
shoot.
build new. There are a few of many. Number one is like if you are working, if you are landing your job into Azure today,
Mm-hmm.
as of when you are started it, I think when you have started, you have been facing a similar revolution of having this notion of Linux operating system, and then you
Mm-hmm.
see the bombardment of virtual machines in the cloud
Mm-hmm.
space, and then the thinkings change of the people. Do I have to manage virtual machine myself, or I need to buy one? Similar to the model called build versus buy. And then we see the adoption of Azure, AWS, Google Cloud, different
Mm-hmm.
or different cloud provider came into the picture. Within the container revolution, it started the orchestration revolution. Orchestration made you need like you have to manage service meshes, you have to manage ingress
Mm-hmm.
controller, you have to manage proxies, you have to manage monitoring observability solution, and you have to manage and you have to be able to understand how microservices application behave. And sometimes you deal with a plethora of containers and the plethora of technologies. For that, can you, what is actually you give to the people consideration, because the technology stack compared to the virtual machine era, it's people say this is a huge one. Now you have to do, because remember container can give you the sandbox environment,
Mm-hmm.
and virtual machine can give you this environment plus the networking and storage capabilities inside of it. But with the container wave, these capabilities is off from you. Now you, if your application need to interact with other container running in the cluster,
Mm-hmm.
you have to networking set it up for you. You have to set the storage, and you have to set API gateways so much into it. So having like this consideration, what do you actually suggest people who diving into the Azure today, and
Mm-hmm.
they have really experienced this new revolution called containerization wave? And now with the containerization wave, there's a platform engineering wave is also coming up. Like what you give people, startup plus individuals and plus the companies who are actually investing time to using Azure services. What is the best way to go through this containerization wave and this newer innovation happening in that space?
So, what was the question? How would I
Yes,
approach the containerization wave if I would be new to Azure? Is
yes,
that?
yes, absolutely, absolutely. Basically, like if you are actually even a new beginner into the Azure today, I
Mm-hmm.
need to face container orchestrations, AKS.
Mm-hmm.
How do I start it? Because there is a journey behind
Oh
a
yeah.
container to the orchestration wave. It's not just a one day journey.
Oh no, 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 no. I think it starts with the foundation, right? The fundamentals. So I briefly discussed them, but I think they're buried under all the stuff that I just shared, right? So I think that the foundation or the fundamental components like computing, storage, networking, security, databases, right? That these components are the building blocks of basically everything. So if you look at virtual machines, same thing as Kubernetes, right? Or containerization, if you will. The layer of abstraction is a little bit different, but you still need to deal with an operating system, not in the same way if that you would deal with a virtual machine. But a container is basically an operating system in itself, right? Then we need to deal with storage. We need to deal with networking. I need to think about security. So Kubernetes basically is a mini data center in itself, right? So it's really easy to start messing around or playing around with the hot new quote unquote new technologies. But do you really understand what happens underneath the hood, right? And the same goes for the cloud. It's not something different that we're doing right now than 10 years ago. right? We just have a different layer of abstraction, and we shifted the responsibilities to Microsoft, for example, to take care of the building and the power and cooling and other stuff like hardware provisioning and all the other things. And we consume that now using the portal or the ARM APIs, or using the CLI, which communicate with the API again. But they built this management layer on top of it, which enables us to consume these resources. But underneath the hood, we still have to deal with networking, storage, and compute, and etc. Right. So, long story short, focus on the fundamentals before diving deep into one of these technologies, and also give yourself the time to learn. You just mentioned already, it's not a one-day journey, right? So it takes ages. Now, ages is too much, but it will take pretty long, right? And that's something that I usually forget or tend to forget, is that I have all this experience and knowledge in my backpack, but I forgot about it. I just use it without realizing that I use it, right? Because I've been doing this for 15 years. So you should give yourself the time to wrap your head around certain topics, and just start at the beginning. Right? It's not that within 1 year you're going to be successful as a cloud architect. Right? You need to start at the beginning. So start as a support engineer, and then eventually a cloud engineer, and then eventually start thinking about becoming a cloud architect if you really know what you're doing. Right? I hope that makes sense.
Yes, absolutely, absolutely. I think these are the most common question people obviously ask in these days, because if you look at the cloud market is actually more and more oriented toward cloud native technologies. If you happen to use Prometheus yourself, you have a Prometheus in the cloud as well. If you happen to use containers in locally, when you go to the cloud, you use Azure Container App. If you
Mm.
use Kubernetes locally using a mini cube, you go to the cloud, you use Azure AKS, EKS, GKE. So basically, like people think like it's just is a ladder how you actually go to that position. But definitely, what you actually suggest, focus on the fundamental, because that is
Oh yeah.
actually will maze. Actually, that is requirement from you currently. If you don't understand anything, forget about AKS or the different cloud. Look at the container and how the container works. If you doesn't able to understand as of today what Kubernetes is, let's pave your way to the path of how orchestration engine works and why you need more, why this orchestration web exists. So so before I let you go, there are some wonderful announcements
Uh-huh.
in the MS build. Some of them are my favorite one. If because I've been using Azure AKS for my company's project, and we look into it when we have a build coming up. What latest from the AKS cluster? Number one, you can begin with, we have Azure Linux in space. Azure announced today, yesterday, I guess, is for me is today, because actually that announcement is came very late when I'm sleeping. I watched it in a few hours
Mm.
back. So Azure Linux is now in the horizon. Robin, can you give us a small intro? What Azure Linux is, if people are really just heard
Mm.
about?
Oh yeah. We're gonna plug streaming clouds a little bit. Well, we had the person who is in charge of developing Mariner, right, which is Azure Linux. They changed the name. Microsoft is really good at renaming things. I do love the name of Azure Linux, but it's basically Microsoft's own distribution of Linux. So they developed this from the ground up using, I think they used Red Hat, so it's not completely from the ground up, but they developed their own distribution. They're completely in control of that distribution. So that put them completely in control of the whole chain, right? I cannot find a better term now, but it is Microsoft's version of Linux developed in-house. So yeah, and you're frozen. Oh, there he is again. You're still here? You're muted? Yeah.
Yes, yes. I'm still here, still here.
Okay, man. Good. Did that make sense? Or you missed me
Yes,
a little bit?
absolutely. No, I think I completely I lost few of the words, but I totally make sense
Mm.
like what the Azure Linux is. But definitely there are some wonderful news. I share the link with the people who can watch some of the news as well. There are one of the keynote session by the Mark Rasonich, and they give a wonderful insight. I think the one thing I really liked about as an AKS user is his ability to attach node pools instead of just a disk to your pod, because
Hmm.
that is recently announced today, because it's happening. I think we all know you create a persistent volume, you create a persistent volume claim, and then the pod actually using, and then there's storage classes for it. And after detaching and attaching, it takes a lot of time. Instead
Hmm.
of creating only just one disk, Microsoft has give us ability to create a node pool of disk, meaning attaching and detaching is just a second away from you. So that another best news from you. I think regarding other news, they announces some VASM as well.
Hmm.
VASM announcement as well. Like you can create micro VM. One of the demos that Mark shows is really interesting. He create, I think, 300 micro VM in less than a second, or I think it is a I have less than a second, I guess.
Hmm.
300 micro VM, how fast it is, and they're actually using these VASM technologies under the hood. But I think one is for me as a cloud native ambassadors, both of us, is really interesting. Is Azure announces the Prometheus, managed Prometheus for Azure user, and Robin will tell us what it is if people doesn't already know about Prometheus.
Oh, that's good. This is an extent. Yeah, well, it's already in the name, right? It it extends Azure Monitor to use Prometheus. So if you're already comfortable with Prometheus, and you have, for example, a lot of Grafana dashboards that you're comfortable with, then you can, of course, deploy Prometheus in your own cluster and manage everything yourself, or shift that responsibility, like we did with data centers and everything back in the day, towards Microsoft. So then Microsoft is managing the Prometheus instance, installation, deployment, whatever you want to call it, for you. And we'll also configure your cluster to be, um, streaming. Well, they're scraped anyway, but so that your metrics end up in the Prometheus instance, right? So, and on top of that, you can add managed Grafana because that one's GA as well.
Yeah.
So then you have Grafana and Prometheus that you can use for your dashboarding and your alerting and everything.
Yes, absolutely, absolutely. And I think for the Prometheus, I think it's a suitable service for the people, because let's say Robin and I'm using, we are the cloud developers or the cloud application developer actually. Our job is not to implement and understand how the Prometheus and observability stack work. Our job is to have an application running that has a
Mm.
business logic inside of it. So we can
Mhm.
spend more time of innovating the business need, regardless of implementing or installing and upgrading and managing Prometheus. It's not a good choice. So having a managed solution is way simpler and way easier. And I see it in AWS, all the cloud provider observability. I'm a huge fan of observability. If you don't have observability solution, the job is not very easy. You have to look at the dashboard, how your app works in the real world production environment. It looks so
Mm.
wonderful, appealing when you've done a wonderful job, and dashboard give you the insight of what your work is actually happening within the dashboard in the real world use cases. And being a best fan of the observability, having these services is wonderful. So there are two other we can talk about. But what is your favorite one? There's a Dapper in the Microsoft who has
Mhm.
more innovation into it. Kata, there is one of my favorite project. But what is the
Mhm.
most wonderful news that you think as of today after watching some session from the MS Build?
Ooh, that's a hard one. Um, I think I really like the Azure Linux one because a natural progression would be a read-only operating system, so that you already take every possible compromise out of off the table, right? Because your node, which is running your containers, is read-only, right? Of course, it will introduce some problems with empty dirs or some other Kubernetes components, but I think that one, or I got like 5 of them listed out here, so that's why I looked to this way. But what I also really like is the
Yes.
Azure deployment environments. I think because that is a small step towards self-service, right? So I really want to see where Microsoft is going to be taking that, because it's all about developer enablement, right? We have so many apps and so many business problems that need to be solved nowadays, and we just have a limited amount of developers and technologists in general, right? So it's all about self-service and enablement. So yeah, I'm really looking forward to what that, or where that will go.
Yes, absolutely. I think that's a big news for the Linux users as well, who have
Mm.
been actually like about the Linux environment as compared to the Windows. So that's the big news for those people. They can stay in the Azure world and working with Linux, and that is comfortable for them. And basically, a self-service is actually a solution for the developer. Otherwise, their job is not easy, and they actually start blaming CNCF and all of the ambassador. Why are you keep adding more and more open source project to the world? And this make our life so much difficult. So having a
Oh, yeah.
self-service is actually the key native way to take a bit. But I think for before I let you go, there is one two more I really like about it after watching the session with Jonnychipz. Is number one, they introduce a project called
Oh, yeah.
uh,
Copacetic.
and then there's a project they call, and the Microsoft is always choose very tough names. I
Mm.
don't know why. And I think, how do I pronounce it? Project
Copa.
capacity.
No,
Yes,
copacetic.
yes,
Copacetic.
capacity.
Yeah. Yeah.
So that
I'm
is
really excited about this one, to be honest. Yeah.
yes, because I'm working with the Parallels open source too, and we're
Hmm.
recently integrating the Trivy GitHub action that just only give us the vulnerabilities we have in our container images.
Hmm.
Now we need to solve ourselves. But if
Uh-huh.
the Copa tool is actually exist in our repository, this look at the result from the Trivy scanner,
Hmm.
and then they patch it. This is
Yep.
awesome. This is simply
Yeah.
and wonderful tool too. I think this will tool that look at the trivia and then actually solve some of the problems. As then actually it's actually solve some of the problem. And then there's another one I have to work. I think I have to see who is actually working on this. And then Robin, you have to find some friends on it as well. That's called confidential containers.
Mm.
Is similar to Kata container, but that's called KCC, Kata Confidential Container. I think the
Hmm.
idea behind these containers, if you have something that you couldn't share with the rest of the people for the compliance purposes or the security purposes, sometimes your containers output some of the very useful information regarding which port is actually opened. If you
Hmm.
drill down in the start the container, it lists down on the output what the container is actually exposed into. Some people don't want to expose some of the very critical information. For the confidential containers, there's another news from Microsoft, I think, but there are so many of them. But we will
Oh, yeah.
cover again. But we meet again next time in June or July when this Robin has enough time for it. So, Robin, final thoughts to leave of people, what are their final thoughts for people who are using Azure
Hmm.
and are they are architect for a very long time? They are actually have new teams actually building up. What is the success strategy look like for them?
One more time. What would you like?
I just want, can you suggest like what the success strategy or success roadmap for the Azure architect will look like in the future?
Yeah. Okay. Um, yeah, basically everything what I just shared. Now, let me think about that a little bit longer, because it's something that keeps evolving, right? So I think one of the key ingredients that I heavily use is I spend like 2 years of just building some software myself. So I'm nowhere near a software engineer. I have an infrastructure background, but I am dangerous enough to blow stuff up with Python and with Golang. And why did I do that? Because that enables me to better understand the developers that I work with on a daily basis, right? So it's DevOps or platform engineering or whatever you want to call it. But we have to enable each other, right? We have to understand them, they have to understand us, and then together we create the best solution that we can create. So the better I understand them, it's the better I can perform my job. So if everything that I already said, plus some development skills, or at least know enough about software development, one or two languages to expose yourself to different concepts, will go a long way.
Yes, absolutely, absolutely. Having to understand the mentality and the existing knowledge of the team is really helpful for being an architect as well. But Robin is a wonderful person to engage with those discussion. He has running a podcast for his own channel. It's called Streaming Clouds. It's been
Mm-hmm.
some wonderful topics, wonderful podcast streaming it. I believe Robin has some more plans this year. They might cover some MS build news as well, so please check that out. Streaming Cloud channel on the YouTube. There is
Mm-hmm.
so much more to learn about as well. But this is the part one. This is a huge conversation. We can talk about full 24 hours because this topic will never end.
Oh,
But we
yeah.
have to stop in some way. So basically, look at the existing knowledge of your team. Start with the basic of the container technology or the technologies you are using. uh, Try to conversate with the people, try to have a communication channel that is very useful, and being used, start using a universal language within the company that can everybody, the junior, the senior, every member of the team can understand those languages well. I've seen some of the cases which talk about so many other things, but that's only can grasp by the top leaders, but the smaller team doesn't understand what you're talking about. But with the container wave, the language of the IT has become more easier. That way I see it. People can understand, talk about Kubernetes containers. So basically, look at that knowledge or the language they're using. But Robin is a person to hang out with this conversation. So I will invite him again to have another part two of the same conversation. And in the future, we might take up some technical deep dive content on the
Oh,
various
yeah.
Azure technologies. But thank you very much, Robin, for your collaboration on this podcast. And we will be meeting again very soon. That is for sure. For that, thank you very much for everyone who are listening to the podcast. And we will meet again soon with another episode. The next time I'm meeting with the Covery team who are building the internet developer platform for some of the large enterprises. So that's happening next Saturday. With that, thank you very much. Have a wonderful weekend. Stay safe, stay healthy. Bye bye, everyone.